Okay, so population growth. Basically, population growth is divided into two types. One is exponential growth and other is logistic growth. Exponential growth. See, observe the word exponential. So growth increases rapidly. If there is abundant of resources, that is food, space, availability is obviously essential. If the growth rate is more, then obviously it is supported by food and space. When resources in the habitat are unlimited, each species has the ability to grow. It realizes fully its innate potential to grow in number. And we know Darwin's theory, that is theory of natural selection. So population grows in an exponential or geometric fashion when there is abundant of resources. If in a population of size n, population size is denoted by a letter n, we'll consider birth rate as small b and death rate as small d. We can consider it as per capita birth and per capita death, small b and small d. The increase or decrease in population size during a unit time period t can be differentiated, and the expression is given like this. So when you differentiate the equation birth rate minus death rate into population size, we'll consider birth rate minus death rate as R. So R is called intrinsic rate of natural increase. So birth rate minus death rate can be considered as R, R into N, R into population size. This is very important parameter chosen for assessing impacts of any biotic or abiotic factor on population growth. So we are studying exponential growth. Here population size will increase rapidly. It will increase exponentially. So exponentially means 2 square 4, then 2 cube 8, then 2 to the power 4 16, 2 to the power 5 13. Like that exponentially it will increase. So to explain this concept, for example, if we consider the population, the R value of Norway rat is 0.015 and the beetle is 0.12. In 1981, the R value for human population in India was this much. So, to calculate R value, we need to know birth rate, death rate. Birth rate minus death rate is R value. And in case of exponential growth, birth rate will be maximum. If we observe the curve, we can see one pink color J-shaped curve. Here, this J-shaped curve shows the organism growth is increasing exponentially. Why the growth is increasing exponentially? Because of the availability of resources. And time we are plotting on x-axis and population density on y-axis. So this looks like a J letter, therefore it is called J-shaped curve. So exponential growth or exponential curve is a J-shaped curve. And when we integrate the values, when we plot the graph, observe the equation. So exponential growth equation. Here NT refers to population density after time t. N naught population density at time 0. And R we already know it is the intrinsic rate of natural increase. And E, it's the base of natural logarithmic base. So if we observe this pink color curve, when responses are not limiting the growth, plot is exponential. If there is no limiting factor means availability of resources, abundant availability of resources, then obviously organism growth will increase. So then the plot is exponential. It is J shape. So any species growing exponentially under unlimited resource condition. This is very important. Abundant resources condition should be there. Then only population density will increase. And Darwin also explained even a slow growing animal like elephant could reach enormous numbers in the absence of checks, in the absence of limiting capacity. And they had explained one example. So the king and the minister sat for a chess game. And king was ready to accept any challenge proposed by the minister. So the minister said if he won, he wanted only some wheat grains. But there is one condition. The quantity of wheat grain to be calculated by placing on chessboard, that is 1 grain in first square, 2 grain in second square, double 4 grain in square 3, 8 in square 4, 16 like that. Doubling each time the previous quantity of wheat on the next square until all the 64 squares were filled. So just imagine there are total 64 squares. So in one first square, okay, 1 grain fine, 2 grain, 4, 8, 16. So it doubles. And the king accepted the silly bet and started the game. But unluckily for him, the minister won, and the king felt that fulfilling the minister's bet was so easy. Later, he started with a single grain on a first square and he proceeded to fill the other squares, following minister's procedure. But by the time he covered half of the chessboard, later king realized that all the wheat grain produced in his entire kingdom pooled together would still be inadequate to cover all the 64 squares. So this is an example for exponential growth. So population density will increase enormously because of the abundant availability of resources. So they had given one more example. Now think of a tiny paramecium. It starts with just one individual through binary fission. 1 becomes 2, 2 becomes 4, 4 becomes 8. So doubling in numbers every day. And imagine what a mind-boggling population size it would reach if we count 64 days. So this is an example for exponential growth. So in exam, if they ask exponential growth, we need to explain first the abundant availability of natural resources, and then we need to write a graph. So better write a separate graph for exponential growth and logistic growth. So you can divide it into two graphs. In one graph, show only exponential growth rate, and in another graph, you can show only logistic growth. Okay, we'll consider only on the first part. If we look at this exponential growth, here only we can mark and we can tell, and R we know intrinsic rate of natural increase, nothing but birth rate minus death rate. And we also know in case of exponential growth, birth rate is increasing. So this equation we need to write and this graph and mention time on x-axis, population density on y-axis. And below that you can mention J-shaped curve or exponential growth. Next one, logistic growth. What is logistic growth? And we also know exponential growth all the time not possible. There are some limiting capacity. There is some carrying capacity. No population of any species in nature has its disposal unlimited resources to permit exponential growth. We also know all the time exponential growth is not possible, which results in competition between individuals for limited resources. Same thing, Darwin's theory. So competition will exist and struggle for existence, then survival of the fittest. Only the fittest individual will survive and reproduce. So the governments of many countries have realized this fact and introduced various restraints with a view to limit human population growth. So all the time exponential growth is not possible. In nature, a given habitat has enough resources to support maximum number. Environment can support some maximum possible number, beyond which no further growth is possible. So that factor, that environment supporting factor, we can call it as nature's carrying capacity. K. So threshold level. A population growing in a habitat, if there are only limited resources are available, it shows a lack phase. Then followed by a phases of acceleration and decrease. So once the population density reaches the carrying capacity. Now observe the graph. So here we are observing a blue line. This is logistic growth curve. Observe carefully, the population is growing, but here it reaches the carrying capacity limitation. It cannot go beyond carrying capacity. And it looks like a S, therefore it is called sigmoid curve, S-shaped curve or logistic growth curve. And the letter K indicates carrying capacity. So if we differentiate the equation, see observe a plot of n in relation to time results in a sigmoid curve. It is described by one equation. So here we can observe the equation. N we know already, it is population size, population density at a time t. And R we know it is intrinsic rate of natural increase. But in logistic growth, there is a limiting factor. That limiting factor, we call it as carrying capacity. We can observe the curve now. It is growing, it is increasing, but once it reaches the carrying capacity, it cannot grow beyond that. It cannot grow beyond that. So since resources for growth for most animal populations are finite and become limiting sooner or later, logistic growth model is considered more realistic one. So these are the two growth models, but in exam while writing, please write separately. Both exponential growth and logistic growth, mention in two graphs, and don't forget to mention time on x-axis and population density on y-axis. So exponential growth practically not possible all the time, and logistic growth is the more realistic one. Any doubts?
No, ma'am.
So you understood both the curve?
Yes, ma'am. Both the curves are clear now.
Okay.